astronaut Neil Armstrong takes his first steps on the moon and says,
"One small step for man,
one giant leap for mankind!"
Welcome to my moon colony, Neil Armstrong. I've been expecting you.
Coming in for a landing.
Oops! No! Neil! Astronaut Neil Armstrong!
I'm sorry, Sean.
It's okay, Mindy. Accidents happen. Let me just reach down and get him out. Ugh. I can't reach it. The hole is too narrow.
Maybe my arm is small enough.
It's gonna be okay. It's gonna be okay.
My arm doesn't reach far enough.
What if it's not okay?
Neil Armstrong was an astronaut and aeronautical engineer who used engineering to solve big problems like how to design a spacecraft that would safely put a human on the moon. If you want to learn more about him, check out I Am Neil Armstrong, written and read by Brad Meltzer. The link is in the description of this video. So the problem here is that Sean couldn't get the Neil Armstrong action figure out of the hole. Well, Mindy imagined that her arm might fit, but it didn't. So now we need to imagine and plan a new solution. We're going to create a robot arm that can reach things that are far away. To create your robot arm, you're going to need a few materials. You're going to need cardboard, straws that are cut into 1/2-inch pieces, scissors, masking tape, yarn, and the robotic arm template that's available to download in the description of this video. So to create your robot arm, you're going to need this template, and you're going to cut it along the dotted lines, but not the straight lines. With a grown-up's help or a friend's help, you can either trace the outline and cut it, or you can tape it onto the cardboard and cut it. So I have my arm, my support strap, and 4 fingers. Go ahead and take the finger template and fold along the straight line. Next, you're going to add your fingers onto the arm. Then secure your fingers with some tape. So then you're going to take your straw and place them in the middle of your joints. Then you're going to secure them with some tape. And then you're going to repeat that with all of the other fingers. Then you're going to take your string and put it through the pieces of straw. And you may need an adult's help for this. And then pull it so that it comes to the end of the arm. Cut it so that there's about 1 inch at the top, and secure it to the back of the finger. So it should look like this. And then you're going to repeat that for all of the other fingers. So then you need to attach your support strap. Flip over your robot arm and secure the piece to the back. Then loop it in front, but make sure to leave enough room so that your hand can fit underneath. And then secure it to the back. So now that you've completed your robot arm, the next step in the engineering design process is to test it. So you can test it by trying to find a small object to pick up, or you could ask a person in your life to place a small object like a marshmallow in a difficult spot for you to reach. The next step of the engineering design process is to improve. So how could you make your robot arm even better? Could you use different materials, add length, or even add more fingers? Next, you can combine various household items to make your very own robot arm. You can use a tennis racket, kitchen tongs, and even shoelaces to help you pick up things around the house. Then, compare it to your cardboard robotic arm. Which one works better and why? The final step of the engineering design wheel is to share. So tag KET in pictures of you with your robotic arm, and if you like this activity, check out the game Jet's Bot Builder on pbskids.org.